Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. The starting material is 2-methylcyclohexane, 1-ol, a cyclohexane ring bearing a methyl group and a hydroxyl group on adjacent carbons, specifically 1-methyl, 2-hydroxycyclohexane or equivalently to methylcyclohexanol. Moving on to the next step. Acid-catalyzed dehydration of 2-methylcyclohexanol under heat. The elimination of water from 2-methylcyclohexanol follows Zaitsev's rule. The major product is 1-methylcyclohex, 1-Na, the more substituted alkene, where the double bond is between C1 and C2 with the methyl group on C1. Thus, A is equal to 1-methylcyclohex, 1-Na, also written as 3-methylcyclohexane depending on numbering, but the key feature is a trisubstituted endocyclic double bond adjacent to the methyl-bearing carbon. Moving on to the next step. Reaction with cold dilute KMnO4 to give B. Cold dilute KMnO4 is a mild oxidant that performs S1-dihydroxylthione of alkenes, converting C is equal to C into a vicinal diol. So, A is equal to 1-methylcyclohex, 1-Na is converted to B is equal to 1-methylcyclohexane, 1,2-diol, a diol where C1 bears the methyl group and O, and C2 bears an O. And for the final step, CrO3 is a strong oxidizing agent. It oxidizes secondary alcohols to ketones and primary alcohols to carboxylic acids or aldehydes under controlled conditions. In B, C1 has a methyl group and an O. This is a tertiary carbon? No, C1 in the ring has two ring carbons, one methyl, and one O that makes it a tertiary alcohol, which CrO3 cannot easily oxidize. C2 has an O with two ring carbons and one H, that is a secondary alcohol, which CrO3 oxidizes to a ketone. Therefore, CrO3 oxidizes the secondary OH(C2) to a ketone, while the tertiary OH(C1) remains. Tertiary alcohols are not oxidized by CrO3. The product, C, is 1-hydroxy, 1-methylcyclohexane, 2-1, i.e., a cyclohexanone ring with a methyl group and hydroxyl group both on C1, the carbon adjacent to the carbonyl. This matches option C2-hydroxy, 2-methylcyclohexane, 1-1, cyclohexane ring with is equal to O at C1 and O plus methyl at C2. Why other options fail? A. A1, 2-diketone product would require oxidation of the tertiary alcohol, which does not occur with CrO3 under normal conditions. B. An enone, 3-methylcyclohex, 2-N1-1, would require dehydration after oxidation, which is not part of the reaction sequence here. D. IChO, aldehyde, side product would require a primary alcohol intermediate, which is not present here. Therefore, the correct answer is C. Therefore, the correct answer is option C.